Let me introduce me first. My name is Jun Li from the largest security company in China called Qihoo 360. We are from the wireless security team called Unicorn team. This is my colleague, so he will introduce himself.
Hello, good morning, everyone. My name is Intao Zeng. I came for Qihoo 360. We are here to talk about
security use.
Security of car keyless interesting system.
So as anybody can tell that his English is not very fluent, but he has done the majority of this research. So I will be translating for him. But I think he deserves a round of applause because he's so, yeah. Okay, thank you everyone. So let's get started. So this is the passive keyless entry system that how it works. So there is a car body control module. You will authenticate the car key fob in order to open the car, start the car. So it has it works with at two frequencies. One is the 125 kilohertz communication. Another one is the ultra high frequency at for example, 315 kilohertz, megahertz. So this is the car key fob. It's a key. So in the key fob it has a backup transponder. So this is when the passive keyless entry system fails. So for example, the battery died. There is a backup option you can use just to authenticate to the car. So for example, you plug in the key, and so using the mechanic locks to open the door. But when you start the car, they will using RFID device, the backup transponder to authenticate the key fob. But when the battery is working, so when the driver approaches the car, and he will press a button on the doorknob, or just a capacitive sensor. So it will activate the car. The car will send the authentication request like signals to wake up the car key. The car key, as you can see it here. Here is a wake up pattern detector. So they have pre-programmed wake up pattern in the car key fob. When the car transmits the wake up pattern, and this car key receive that signal, it will compare that signal with this wake up pattern. So if it's matched, then the car key fob will use the ultra high frequency transmitter to transmit its ID, and it's encrypted. The ID is encrypted with a random number sent from that wake up signal, with that wake up signal. So the encrypted ID will be received by the car body control module, and it will decrypt it and to say if the key fob's ID matches the ID stored in the body control module. So can anybody understand this? Don't have questions? Yeah, okay. So this is basically what I have just talked about. The car transmits this wake up pattern with a random number. It will be later used as a sort for the encryption algorithm, and then there is a time constraint enforced, because if the key fob cannot respond within this 27 milliseconds interval, this session will be stopped or dead. And so this is a normal authentication flow. So when the key fob receives this wake-up pattern and it matches the wake-up pattern stored in it, it will respond with its ID encrypted using a symmetric key, and the sort just sent in the 125 kilohertz wake-up pattern. So that's how it authenticated with each, how the authentication between the car and the key fob works. So we are actually going to, because we cannot get the encryption key. It's not absolutely secure. Actually, we gave a talk last year on how to extract the symmetric key, but we are not going to talk about that today. So we are going to do actually relay attack. So we will, like, when the user is like shopping in a supermarket or working in their office, like in the buildings, we can put a device near him and relay the car key fob's communication to the body control module of the car. So we can activate the car's doorknob and send out the 125 kilohertz signal to the car key, and then we just relay their communication, both high frequency and low frequency. So we're going to talk about that. So this is the 125 kilohertz signal transmitted by the body control module. So we tried different antennas with different inductance, and so this process is very arduous. I think you'll have to try it many times to choose the best antenna, and so this is how it works. Because the signal is so weak, you can say it's like 0.16 volt. So it's so weak, you have to amplify it and demodulate it and get those 1 and zeros and relay that to the other module, and then modulate the carrier and transmit to the key fob. So decode the data. So this is how after the demodulation, you can see this envelope here. After the demodulation, we get this kind of pulse signals. So you can see this is using the different encoding schemes. And this is non-return to zero. This matches. So we just took the specific keyless entry chip, for example, but there are other PKE working at different frequencies, but the principle is the same. So we can just change the frequency to let this device working with other systems working at different frequencies. So I want to check at that point to see if anybody can understand me. So any questions? No? Okay.
One question.
Yeah.
It appears to me that the car is always pulling for the key. Is that correct?
It's not always. Yes, certain cars will transmit the wake-up pattern periodically, but most of the cars they require you to press on the doorknob. There is a capacitive sensor or a switch, so you activate that the car to transmit that wake-up signal. Yeah.
Thank you.
Okay. Oh, very good. Yes. So we at first we sort of using software-defined radio to implement this kind of attack, but we found it's too expensive and very bulky, very large, big. So we created a device like this is small. Actually, it can be smaller, but it's small enough to hide. So software-defined radio usually it's very not large and very expensive. So we didn't use that. We used we will introduce the chips we used. So to demodulate the data and to transmit the data. So I will let my colleague to introduce this part. So I will translate for him. 你讲，你用中文讲，我就翻译。
首先的话，汽车就是在触摸它那个汽车把手的时候，它会发出一个15K 一个载波信号，来唤醒那个遥控的一个唤醒。
So that when the user touches the doorknob, the car will transmit a wake-up pattern at this frequency to actually it's intended for the car key fob, but now we are trying to illustrate the process of relay attack. So we
然后它那个我们的设备，然后解调了它那个低频的一个信号之后，就通过一个射频前端给它接收下来，然后通过那个再解调的方式，然后把那个低频的15K 数据通过我们CC1101给它发射出去。
You can see that we use the low frequency amplifier to amplify the signal we just mentioned. At 0.16 volt, we amplified that signal, and we used this module A. We just deleted. We will introduce the module later. We used module A to relay that data to another module, and then we used this module to actually this chip is with this module. This chip will be used to modulate the data, so it can is used to use the data to modulate a carrier to transmit to the car key fob.
然后通过那个再把那个通过闭模块的1101模块，把那个15K 的数据给解调下来之后，通过 EM4095 芯片，然后将它那个高频的一个载波信号的一个数据给再以15K 的一个频率给它发射出去。
So when the key fob receives the wake-up pattern and it will transmit via the high frequency channel to transmit its ID, encrypted ID, and we will use the module B to receive and demodulate this data and relay it to module A, so the module A can relay the encrypted ID to the car. So actually this distance is like 300 meters. Yes, it's very far away. So,
然后它遥控的话，它接收到它那个115K 的一个信号之后，它会把它那个把程序给唤醒之后，它会把它一个 ID 给通过315兆的方式给它发射出去。然后这时候我们通过射频模块，我们可以把它这个信号给采样就给它解调下来，然后再以同样的方式给它传到那个模块 A 上面。然后模块 A 的话，可以再通过一些射频模块，再把相同的一个信号给它发射出去。
So that's actually he's explained one more time how this module A can transmit the key fob's data to the car. So let's go on to the next slide. So we are trying to explain the time constraint. At first, we demodulate the data and we store it in memory, and then we transmit it. So that will introduce additional delay. But so this attack won't work. But later we found out that in their technique documents, we found that they're enforcing the time constraint. If you cannot reply within a certain time, it will close the session, maybe like that. So anybody has questions for now? Okay. Okay. So this is hardware. We are going to talk about how we built this hardware. This is module B in the figure. This is module. This is module. No, module A. This is module B. So you can see there's a three-dimensional antenna. This antenna is three-dimensional antenna. So it's not like the normal coil you see. It actually you can see here. So you can see this antenna. It have like three coil, one point in different direction. So it's 3D. So it's better reception, I think. And we use 你来讲吧。
换下一页吧。
不，你讲一下这几个模块。
下面。
OK。
然后这蓝色这一块的话，就是那个模块 A， 它负责是传输它那个中继的一个数据，以及把那个汽车一个信号给重放跟那个接收下来一个模块。
So this module, actually, you can see that what we have denoted with channels. The channel 1 will receive will transmit the car's data. So the car will transmit the wake up pattern working at this frequency, and this is used to transmit that data to the key fob. Okay, this one is used to relay the high frequency, the encrypted ID of the key fob to the car. So this module is used to receive the high frequency data, the signal from the car key fob. And the other module is module B. No. It's the module A. The module A. So this is the module A.
它们模块 A 跟模块 B 的话，它其实是分为两个不同的一个设备的。它只是说模块 A 的话，它只是用到了一个AS3933的一个射频前端，把那个汽车的一个15K 的一个信号给通过射频前端的方式给它将几毫伏的一个信号给它提升到大概几伏，就是 MCU 可识别到一个电压。然后通过这个射频前端之后，我们可以把这个射频前端的一个数据给直接传给我们 CC1101，就是信道1的一个模块一个发射的一个数据的整合。
So he had just explained the module, how module A works, just like I explained it. There is a chip will amplify will modulate the signal from the car, modulate the data from the car and transmit to the key fob. And the other module B, will be this one. This one is used to receive the 这是用来传输的嘛？
这个的话就是125K 一个发射的一个芯片。
So this is the antenna used to transmit the 125 kHz signal to 传给汽车的嘛？
对，这个是传给一个钥匙
to the key fob. Okay. So when the key fob sends the ID, encrypted ID, so it will be received by this module, and then this module will transmit the data to here, and then this module will demodulate it and modulate it modulate the signal via this module and transmit to the car. So this is a high frequency relay first from here to here, and then here and here. The car key fob to the car. Okay, and the low frequency signal is like this. the car will transmit the low frequency data to this module, and this module relates via a high frequency module to the other module, and the other module will use this antenna to transmit the wake up pattern to the key fob. So this is how it works. First, the car transmits this signal, wake up signal to this module, and then this module relays that signal to the other module here, and then this module modulate and transmit that signal to here, this key fob, and then the key fob will transmit via high frequency this ID, encrypted ID, to this module. It will be received by this module, and this module will relay the signal to the other module here. This antenna is used to receive. This antenna is used to transmit. So it will be received by this one. And this one will transmit the signal to the car. So this is the authentication flow. So let me show you the demo. So this is the driver, the owner of this car. So he goes to shopping, goes to buy a cup of coffee, and my colleague is holding the one module near him, just like he is going to buy a cup of coffee as well. And I use another module. So this is. I used another module to open the car. You can see I pressed a button on the key fob. So that's how PKE system works. You don't have to pull off your key fob. You just remain in your pocket. You just press the car. The car will detect if the key fob is near the car. Actually, the range, normal range, is intended to be used within 1 meter. So that's obviously not 1 meter. So there is another video. Okay. This is a different car. Oh. Okay. Yeah, it's not legal to steal cars, so. The conference, this projector is monitored by the government, right? Actually, in my country, when we present contents like this, we would say we are going to protect the car. So the reason we give this presentation is to protect the car. So we'll give you some advice how you can improve. But I think it's more free in this country to say we are going to steal your car. I'm going to the mirror option. So if anybody has questions so far, so I can take this opportunity to answer that.
Hey, so the only radio chip you used was the CC1101, right?
You mean what?
The
Pardon?
radio chip.
Yeah, yes, yes.
So instead of using like 4 of those, if I understand the diagram correctly,
Can you louder?
instead of using the 4 chips that is shown in the diagram, can't you just use 2 and then switch between transmit and receive?
Okay, you mean just use 2 chips to do receiving and transmitting, right?
Yeah.
I think using the 1 chip for receiving and another to transmit is better because there is like interrupting, because you don't know when the other thief will press the button. So if the other thief is press the button when you are in a receiving, you are in a transmitting mode, or maybe it will like fail.
Okay.
So we use 2 separate chips to achieve the high success ratio. Maybe.
Sure.
So.
And the frequency of communication between the car and the chip, in one slide I saw it's 125 kilohertz, or was that megahertz?
You mean the communication between
the car and the chip, the key fob, sorry.
Okay, there are 2 different frequencies. The high frequency is like when you press the key fob, the key button on the key fob, it will transmit the like the rolling code at high frequency, but it's using the lower frequency to activate the key fob. The lower frequency is at 125 kilohertz.
Ah, okay.
I think that may be because they are control the range, because you are intended to use the key fob within 1 meter.
Yeah, but does the CC1101 go that low? Because I thought it was from 1 megahertz to 1 gigahertz.
You mean the chip?
Yeah.
We use another chip to transmit the 100 and
okay.
the 225 kilohertz.
Okay,
signal.
yeah.
Yeah.
Thanks.
What is the range that you can perform the attack on?
Actually, we are going to show you.
Could you repeat that question?
What question?
This question.
Okay, he is asking the range. How far can we achieve? Can we mount the attack? So when the user's key is put in his pocket, so we will put a module. How the distance between the module and his key fob? Maybe I think we have achieved 2 meters. Yeah, it's enough, right? When you queue in to buy coffee, it's enough. And the relay attack range, we have achieved 300 meters, direct distance. But when there is obstacles, I think it's when you park your car along the road and you are buying something in a market or a shop, we can mount the attack, I think. So,
why do you use the same frequency of 350 megahertz between the 2 modules, and that's the same frequency as the key frequency?
yeah.
So why are you not using some other frequency for the communication?
Because we just chose the chip. I think because at first we would think like there might be interference between, right? You mean interference? That's what we want to mention.
Yeah, that's what I was wondering.
Yes. At first we were worried about this, and then we done some experience. It's working. So, yeah. I think that might be because they are not transmitting and receiving at the same time, maybe. Or just we can adjust the antenna's direction antenna, maybe. Yeah, we thought about that, but it's working now. Yeah. So we were trying to play the video. So this is another car. Hmm?
不用声音了吧？
there's no
而来的隐患，电子控制，
there's
再到整合了
another
网络功能的智能化控制，从计算机信息安全延伸而来的隐患，在带给汽车智慧的同时，也带给它更多
So
的
there's
弱
a
点。
key fob and there's one module. So for the demonstration, actually the key fob should be put in his pocket.
通过复制汽车样式并中继信号
You，can see
轻
this is
松
the
使自动勒
prototype.
索功能失效而打开车门。李军和同事在线的还不是。
Yeah, that's okay. This is all the components we used. So I'll ask my colleague to explain this. 你讲一下这个每个元件干嘛的，多少钱？
这 BQ24107的话，就是一个充电管理的一个芯片。
This is power management chip for the battery. So you can you can just charge this device directly by plugging in a cable here. So it has a power management chip.
然后这下面这个 CC201呢，它主要就是说负责是传输一个低频跟高频的一个信号，以及就是汽车的一个高频的一个信号的一个解调，还有那个调制使用的。
So this CC1101, this chip is used to relay the 125 kilohertz signals and the high frequency signals. We used 3 of those chips. No, not 3. Just each module has 3. So we have 2 modules. We have like 6 of those chips. And there is this chip. This chip is used to transmit the low frequency signal, just like I think that's a question that gentleman have just asked. So we use this to transmit the low frequency signal. And this one.
然后AS3933呢，它主要就是一个射频前端一个芯片，它是把一个汽车发送出来的一个低频信号进行一个解调，然后把它转为一个 I/O 就 MCU 可以有识别的一个电压值。
Okay, this chip is used to demodulate the signal. So to like just when the car transmit signal is carried by a carrier wave. So this chip is due to demodulate that signal and just convert that modulated signal to just like to sweep the envelope of the signal. So the microprocessor can understand that? No, can accept that. So 这个。
然后125K 天线的话，就是说是一个3轴的一个立体一个3轴的一个天线，它是主要是让它钥匙无论是哪一个方向，它都是可以接收到它那个汽车定向发出来的一个信号。
This is the the 3D antenna. So you can see there's 3 antennas pointing at different direction. This direction, this direction, and this direction. So it's 3D. And so this is an antenna, 3D antenna. And this one.
这个就是一个设备上面一个 MCU， 它主要的工作就是说是配置那个射频前端 AS3933跟那个跟那个 CC1101的一个寄存器的一个配置，主要是让它这些工作在具体的一个频段。
So this is the microprocessor used to configure this chip, and this chip. So you have to put them in different model like receiving, transmitting, or whatever. So this microprocessor is used to configure those chips in its corresponding mode. So this one. 这个。
这就是一个它上面的一个天线。
This one is this antenna, 6 antennas, and the PCB board is actually this number is cost in euro, so it's only cost like 20 euro. It's much cheaper than a typical software-defined radio platform. So the range one is attack distance. So if you, for example, the owner, the car owners may be shopping at this shop, but we can open his car in like 2 blocks away. This is you can see it's 1,000, more than 1,000 feet. It's 320 meters. So it's enough so the driver won't discover the car was stolen. So some of you may ask, how can you, after you drive out of the range, of the relay range, the car will stop or whatever? So that's a question. Actually, we have done some experience. Once you have started the car will, some model will no longer looking for the key fob unless you turn it off and turn it on. So you can drive until you're out of gas. So this is another range 2. Range 2 is the range between the module and the victim. So we have achieved like this 2 meters. You can see the light is still blinking. So the car key fob, it has detected the this wake up pattern sent by this module. This is a prototype. So yeah, the question I'm trying to answer with this slide is that after you start the car and you drive out of the range, so what happens is the car was still working. If some car might remind you that you cannot detect key fob on the panel, instrument panel, or display text saying that I cannot detect the key, but it won't stop, will not like turn off the engine. You can still drive. So the attack scenario is like this one. Your owner is in his home. You just like, or shopping mall. You just walking along with him, or like he's having a cup of coffee. You just put the device at the table near him, so you can drive away. So the reference documents will be available later. So possible countermeasures. So how can you protect? It's hard. Relay attack is very hard because we are not breaking the encryption algorithm or the bypassing the authentication procedure. It's very hard. So I think the most effective one is no, there's no effective countermeasure, I think, but you can see you can put the key fob inside a Faraday cage, maybe like a bag with cannot so the module cannot. So when you put the key fob inside the Faraday cage, like it can be a bag made with special material. So can you get this idea? Or so it will stop the communication between the key fob and the module. So, or you can remove the battery and fall back to the old school high-tech key fob. So that just like when you you use a mechanic lock to unlock the door. So just so there is a backup module. So when the battery died or you removed the battery, it will use this backup transponder to authenticate the car key fob. So the attacker cannot open the car without the mechanical key, or he cannot start the car without the transponder to communicate with the body control module. So this is one countermeasure. And the stricter timing constraint. Whatever solution you are using, you will introduce the delay between the different steps. So you can implement stricter timing constraints. for manufacturers, you might come up with some solution. You can detect the key fob relational direction. For example, the distance between it, and using like the 3D antenna to detect the position where the key fob is relative to the car receiver. And yes. So any question?
So which cars, which brands are vulnerable for this?
We have tested. No, is it okay to just name the brand? Oh, actually, last year when I was giving a talk at DEF CON, there is a guy from manufacturer. So yeah. So actually, we tested a Chinese brand, BYD, and we tested on General Motors. Like the car is like Corvette? No. So and yeah, actually it's not limited to one specific module or specific model. It depends on the chip, the solution the car is using. The vulnerable solution is from NXP. They are using like PCF. So what's the specific model of the chip? I forgot. PCF
792.
So PCF 7952. That chip. That actually is a series, is a chip series. So have different model, but the system architecture is the same. So that's the vulnerable architecture and the chips we tested. So it's not limited to specific model of the car.
So you said that it uses a rolling code system, right?
Rolling code, yeah, we did not break the rolling code here.
Yeah. So I was just wondering if you had tried that attack too, the jamming and replay for that.
What?
So Sami Kamkar had an attack called
yeah.
Keyroll. Yeah. So
it's like it's different because actually I have to start over from here to explain how the rolling code. Actually, the talk we gave last year at DEF CON is about how to extract the symmetric key, because the key is derived from a manufacturer code and the initialization value certain to use the algorithm to derive the symmetric key for the key fob. We talked about how to derive the key, and here, as you have mentioned, the Sami's work. His work is like the rolling code is work like this. When you press the key fob to open the door, you will transmit the rolling code. It's inside the rolling code. Actually, I'm just showing a slide. 有没有那个就是 PPT 在这儿？
哎，
就是去年那个 PPT。
去年的我们。
Okay, there is a counter. Before the actually rolling code is the result of encryption. Before the encryption, the contents include a counter value in it. So every time it will check the counter is if the counter is larger than the previously received rolling code. So what Sami did is he jammed the communication between the key fob and the car, and then. When the car owners press the button first key fob first time, he stored the signal, and because the communication is jammed, so the car cannot receive that rolling code to open the door. So the owners find there's no response for press the second time. So at this time, Sami will replay the first signal to the car, so the car will open. So and he will store the second one. So you can see that the car is inside the car, the body control module. There is a counter that smaller than the second rolling code contains the serial number. So the second one is still valid. If the driver If a driver have not pressed the second time, the third time, the second one signal is still working. So once the driver is pressed the third time, the value will be synchronized to the newest counter value. So I don't know if without slide I have explained this clearly. So can you understand me?
Yeah.
Yeah. Okay. So that kind of attack I think has its limitation, because you cannot guarantee the driver won't press another time, and I think if anybody working at the hardware, you can understand how hard it is to do the jamming while you do the receiving, right? So I think it's very limited.
So another question was, if they're using passive keyless entry, do they not use an immobilizer chip, or is it not activated when the car starts?
What?
So some car keys have an immobilizer, right?
Yeah.
So how does this completely bypass that?
How do you bypass that? I think you have to as you can see, their authentication program is stored in this control module, body control module. So you want to bypass that, you have to analyze the firmware for this module.
Sorry, I think I wasn't clear. What I meant was the immobilizer is supposed to work even after you unlock the car, right? I mean, it has to be, if I'm understanding it correctly, the immobilizer in the key has to communicate with the car before it starts.
Yeah.
So this bypasses that?
Yes. Okay. So I just mentioned that when you some certain cars, when you open the door, you will consider you can start the car, because there is no traditional ignition switch. You can plug the mechanical key and turn on the engine. So for certain models, you just put the key fob inside your pocket, and when you open the door, you can press a button and start the car. But some cars, when you press the start button for the second one, for this car,
从机械再到整合，再带给汽车。
For this car, when you get inside the car and press the start button, ignition button, it will look for the key. Will do another round of authentication. But for the previous one, this one, when you press the button on the key knob and the the door handle, it will authenticate the car key fob. And so after that, you can just start the car without any authentication.
Thanks.
Okay. So any questions? Oh, there.
Have you ever thought of combining the two attacks of the extracting the key?
I will actually to extract the key, we found actually the key okay, it's very hard for a foreigner to explain this without slide. The key is derived from the manufacturer code. The code is related to the manufacturer, and another value is an initialization value. So if we find the initialization value and the manufacturer code, which is very easy, we can derive the key. So we found a device that they were selling it on the internet, and they claim that they can use that device to copy the key fob, or so that do that kind of thing, and we extract some of the symmetric key for certain vendors for certain specific models of cars. So we extract part of the keys from that device, and we derived part of the keys we have from the algorithm. Yeah. So combining these two kind of attack, I think it's pretty easy, but you have to find the serial number correspond to the key fob. So you have to at least receive one rolling code, because the car keys ID is transmitted in plain text. So we have to get that and then derive the key, the encryption key. So I think combining it is, yeah, we never sort of combining it.
Because if you if you combined it, you maybe could decrypt the ID and could copy it to another key.
Yes, but this attack is used when we cannot find the key, and we cannot decipher the rolling code. But if we can decipher the rolling code, I think it would be easier, and it's better, because when you steal the car, and you can start it the second time, third time, or whatever. But this one, only one time. You drive out of the range. When you stop the car, you won't be able to start it again, unless you do some replace the body control module. Thanks.
Any more questions? All right, if no question, thank you to Li Jun.
So if anybody is interested in this hardware, take a look here.
And put your key there as well, please.
Okay.